Hey, so I did another video today giving a little talk about these, but I have a couple pieces of the hours of footage I took which actually are kind of interesting. So I put a couple of them together in this video so you can check it out.
So I've finished assembling the boards. I've assembled two of them, and I've used the water-soluble flux, which is pretty much my trick for having a really good board. So you get good quality joints because you can use hella flux. And I don't know if you can see it, but the board looks like super grotty. There's flux everywhere. It's sticky, it's messy. But I wanted to show you this last part, which is super satisfying. Is you get a ultrasonic cleaner. So this is some hot-ish warm water, and before I turn it on, because I think it might drown out the camera, you just put it in the ultrasonic cleaner in just water. It's ideal if you use distilled water, but I use tap water and it's fine. If you're doing low power electronics, you probably want to use distilled because contamination on the board is a leakage path and it can make a big difference to your current. But so just thought I'd show you this. Man, that's really terrible for your ears. That's probably something I should wear earplugs for. Anyway, so now it looks pretty good. And as the final step, I normally grab one of these computer cleaning dust off thingies. I just blow some of the water off. The benefit of that is that if your water does have some contaminants in it, then blowing it off instead of letting it evaporate off gives you a better result. So I'll probably do this a bit more, but I just thought I'd show you what how fast and how efficient this is at cleaning PCBs. And for those who are worried about electronics and water, water doesn't do anything to electronics. You just shouldn't energize the circuit while there's still traces of water. But most of these packages and so on will not allow water in. There are some chips that you should not do this with. So for example, if you have a humidity sensor, you should not immerse it in water. Generally the datasheet will mention something about you not being able to do a wash on the things like buzzers that have open cavities. Sometimes you're not allowed to do that. If you have an accelerometer, like a MEMS accelerometer, you can clean it in water, but you can't use ultrasonic. It just snaps the sensing elements off inside. So learned that the hard way on a couple of them. So after giving it a good drying with the compressed air, I'm now going to give it a quick 1-2 with the old lab hairdryer. Basically you just want to heat the board up. This is quite cold, so I want to heat the board up so it's just above room temperature. So now that the boards have all been assembled, cleaned and dried, I thought I would share this somewhat nerve-wracking experience with you. This is the JTAG programmer. You need to flash the bootloader onto this right at the very beginning, and from that point forward you can program it over USB. But if something's going to go wrong, there's something wrong with the board, some kind of mistake or whatnot, this is the stage at which you're going to notice it. So there is a bed of nails connector on the board over here, and there are 3 steel pins here which basically go through the holes on the board. It goes through the board like this, and you can either just hold it here because it programs pretty fast, or if you have insufficient hands, you get these little clippy things which you lose, so they're like practically a one-off kind of consumable thing, but that clips on the back and then the cable gets held here, and then you plug this into your computer and then voila. So I've cloned the core repository which contains the bootloader, and I have plugged her into the computer, and in the core repository there is a script, doing this one-handed, that will program it, and let's see. Well, hey! It actually works! I mean, that always happens. It always works first time. I'm a professional. Now for the next moment of truth. So we know that the JTAG correctly programmed this board, which means that the chip is probably fine, but lots of other things could go wrong. What we need to check now is, will it actually enumerate on the USB bus? If there's something wrong with the routing of the USB traces or something like that, that may be the problem. Now, I've already done the bootloader code on the prototype board, which I did a video showing how I etched it. So I already know that this bootloader should work in terms of the software. So this is mostly a hardware check. So now we see, if I plug this in, if we get magic smoke or if it properly enumerates on the machine. And it appears like it enumerated correctly. That's pretty cool. Look at that. Manufacturer, AVE community. So it's enumerating as a serial device, and it should work out of the box with the Arduino IDE.